Okay guys, I'm finally ready. Right, so chapter 4, access control lists. Now we did a little bit of ACLs in CCNA 2, but that was very little. So this is a more in-depth look. And so I think we basically just did standard ACLs, and that was IPv4 ACLs, and I think that was it. So this is goes into a lot more depth, into a lot more options. Okay, so we will recap on standard ACLs. We'll look at how what you would use them for and how you'd use them. We'll look at extended IPv4 ACLs as well. So that's where you can actually pick out what protocol traffic that you wish to filter or permit. And then we'll look at IPv6 ACLs, which are very similar to the IPv4, apart from, of course, the addressing. And we'll look at how you troubleshoot ACLs as well. So with standard ACLs, basically, so it's an access control list, and so each list will have one or more access control entries or ACL statements. And so in those statements, you will have permit or deny are the most common uses for it. You can actually make a comment as well, just to explain your ACLs if someone down the track needs to try and figure it out and maybe modify it. And so we've looked at wildcard masks before, both in OSPF and also in the ACLs in Cisco 2. And so, of course, a wildcard mask is normally that sort of inverse of the subnet mask. And so, of course, wherever you have a 0 is bits you do wish to match. Wherever you have a 1 is bits that we don't need to match. Now, I think this rule may have been covered as well. So you can only have one ACL per protocol, per direction, per interface. And so basically it's just the way you can control these things, because if you remember with ACLs, it will check the incoming packet against the criteria, so that addressing plus wildcard. If it matches, that's the only line that will execute. So it'll do a permit or deny depending on what you've done. And so it goes until it finds its first match. And so if you had more than one list for the same protocol, it would be next to impossible to figure these things out. So now it's changing to extended ACLs briefly for whatever reason, I'm not sure. But anyway, with extended ACLs, the difference between a standard and extended is standard can only match source addresses. That's all they can match. With extended, you can match source and destination addresses. You can also match source and destination port numbers. And so, of course, having a knowledge of those port numbers will help greatly. Now, you can actually use some reserved words for some protocols, and so DNS and things like that, you can type that in instead of, port 53. And I suppose it does make the access list a little more easy to understand when you're reading it, by all means. And so, yeah, basically you've got to know what ports are being used in this conversation that you either wish to get through or to block. To help explain how an ACL operates, we've got a good old flowchart. And so we've got this packet that needs a decision, and then how will it work? And so we'll look at the source address, and then from there, you will then look for port 80, and so on and so forth. And so basically, yeah, I don't like the flowchart much, I've got to admit. And so basically what we're doing is we're permitting network A and we're denying network B. So yeah. Anyway, so back to standards. So of course the syntax for an access control entry is access list, and then the number. If you remember, the number 0 through to 99 is a standard access control list. 100 through to 199 is an extended. And so, of course, with the standard, the next thing you do is, are we going to permit or deny? And then you have your address that you're going to match against the source address. So in this case, we've supplied this IP address, and with the wildcard mask here, it's only the last octet that is being ignored. Quick drink of water. If you can't tell, I've got laryngitis. Yeah. And so basically, it's a Class C network, and so this will permit all traffic from this subnet. Pretty simple. So of course, with an extended ACL, because there's more things you can match, there's of course more information you need to supply. And so access list 103, so of course it's extended. Then you actually say which protocol you want to talk about. And so you can do IP, you can do ICMP, you can do TCP, UDP, and a few others as well. But and so in this case, we're talking about TCP. And so because we're talking about TCP, then you can start talking about port numbers. And so basically from here, the first address and mask you supply is the source address. And the second one that you supply is the destination. And then EQ80 means equals port 80. So this is any host from this subnet, again, it's the same as above, to any destination with a port equals 80. Now, there's two ways you can define IPv4 ACLs. They're either numbered or named. And so, of course, I was talking about the numbers there, 1 through to 99. There's also extra ranges in the thousands as well. And so, of course, there's standard ACLs, and, of course, 100 to 199, and there's also in the 2000s for extendeds. If you create a named ACL, you know, you could call it Fred or, you know, inbound internet traffic or something like that. You give it a name, and you also say that it is a extended or standard in the line that defines the ACL. Now, because of the information the ACLs check, the different types, the standards and the extendeds, basically the placement for them is different as well. And so with extended ACLs, because you can get very granular with them, you can actually place the extended ACLs as close as possible to the source that you may wish to deny traffic. And the advantage of that is you don't have to route the traffic all the way to the destination and say, oh, sorry, now it's denied. I suppose the major downside with the extended ACLs, is that because there's more information, there's more comparisons to make, and so there's more processing, so there'll be a little more hold up. Of course, with standard ACLs, they're a bit of a blunt tool. You can only match the source address. And so if you put that right next to the source of the packets, and if you're denying them, you're actually going to block them getting absolutely anywhere, not just to maybe a destination you're wishing to block. And so the downside with that is, of course, you've got to route them towards the destination before you then decide, oh yeah, this is traffic we don't want. I suppose the upside with standard ACLs is because you're only comparing source address, there's less processing required. And so we've got some examples here, and so because this is a standard ACL, it should be as close as possible to the destination. And so what are we looking at? filters traffic from the 10 network to the 30 network. So you don't want traffic coming from these hosts onto this one. And so if you blocked it here, of course, they wouldn't get to anyone. So you might as well just not have them plugged in. And so you've actually got to put it here, because here, oh, must have been another diagram. There was a server on this one. And so, of course, you may well want them to get to hosts here. And so you'd actually do it outbound on this Ethernet interface. And so if you wish to block all FTP and Telnet traffic from the 11 subnet to the 30 network, you could actually apply it here, inbound on the gigabit. And so, all right, here I'm not going to let you get to FTP and Telnet when you're aiming at that. And so, as I said, the beauty of that is you don't have to route the traffic across serial links, which are normally a lot slower. So what is the syntax for the ACLs? So we did look at it before. And so access list a number, and then you've got the three actions, which is deny, permit, or remark, which is that comment that I was talking about. Then you supply a source address and a wildcard mask. And so there are also some reserved words. And so instead of a wildcard mask, if you're just trying to match one particular computer, you can actually do host and its IP address. And that will actually be the same as a 32-bit match. So I wanted to match all of the IP address, and so you can use host. If you want to block all traffic from all sources, well then you can actually do any. Of course, you wouldn't normally block any, but you would quite possibly permit any, or it might be the last statement in your ACL as being a block any. So writing the ACL is only basically the first step. Like the second step to actually have it active is to apply it to an interface. And so I know we've defined it with access list 1, but when you apply it to an interface, you actually call it access group 1. And so you do IP, so it's an IPv4, access group 1, and then the direction, either outbound or inbound. And so you've got to take this from the perspective of the router. Is it going out of this interface from this router, or is it coming into this interface to the router? And so you've got to think of it that way. Now for a named ACL, basically there's IP access list. So this is in global config mode, IP access list. And then we're defining whether it's standard or extended. In this case, of course, it's standard. And we're calling this no access. That's the name. And so now, because you've actually done this named access list, you'll notice that it goes into a different config mode. In the previous slide, if you look at it, everything was in global config mode for the definition of it, and then you apply it in the IF. Here, when you define the named one, you actually go into named ACL standard config mode. And so all of the commands you put into this, it knows belong to that no access ACL. And so deny host 192.168.11.10. And so we're denying that one particular host. Permit any, permits any other host. And so we're just trying to block that one host to getting to that subnet. And then applying it is the same. IP access group, but of course you use its name instead of the number. Now once you've defined your access control lists, how do we check them? If you do show IP interface, it will actually show you any access lists that are outgoing or inbound. You can also do show access lists, and it will actually tell you about those access lists. And so it tells you about IP access list 1 and IP access list no access. Now you'll notice that it gives it a number beside it. And so that actually is a good hint, in that if you wish to edit that access list, if I wanted to stick a line in between That's strange. It's got 15, 10 and 20. I think someone's done some poor editing on this slide. But anyway, it should have been run 10, 15 and 20. If you wanted to stick one in between 15 and 20, you could do 17. So you can actually, when you define the line, you actually put a number in first, and that will actually slot it in. So if you remember from Cisco CCNA 2, the order in which you do the lines, pardon for a sec. The order in which you do the lines does matter, and you need to start from more specific to less specific. And so the host lines should be the first things you do. And then those ones with any statements would probably be towards the end. Because if you have those any statements up the top, that will match any host. And so they will always happen. And so if you've got special treatment for particular hosts, you need to put that at the top of the list. Because remember, first match is what gets executed. Now, more modern versions of iOS have actually sort of done a bit of checking and gone, oh, you've got a less specific line before a more specific line, and so it will actually reorder these things. But I'm going to say nothing's perfect, especially when it comes to programming, and so you probably should plan it out better yourself. So extended ACLs, and so as I said, they're a more granular thing. They take a little longer to process, but they are a lot more precise. So how do we define them? So I'm going to say it's pretty consistent with how we did the standards, but of course there's just more information. So you need to specify a protocol, and then it's source address. You can actually do a source port number as well. And then destination address, which is any address in this case, and the destination port number. So of course with IP you can't specify port numbers because IP doesn't understand port numbers. If you need to specify port numbers, that's when you need to specify either TCP or UDP. With ICMP, you can actually do special lines where you can actually talk about, you know, if you're talking about ping, echo request, echo reply. And so you can actually block echo requests coming into your network, but you can allow echo replies. So if your people from the inside ping out, their replies will come back. And so you can actually do things like that. So if you specify the protocol as ICMP, you can actually specify what type of ICMP traffic. And so the syntax again, so again, it's deny, permit, or remark are the three possible actions. Then there's protocol, then it's source address, source wildcard, then you have an operator, equals, you can actually do less than or more than and a few other things like that. Port number or port name, then a destination address, destination wildcard, and again, an operator, port number, port name. So here we've got an example where we allow requests to port 80 and port 443, outbound I'm assuming. And so access list 103, permit TCP, this is an internal subnet, to any destination equal 80. And the same line again, but equal 443. So what's that going to permit? Yep, HTTP and then HTTPS. Now, I don't know if you've seen this established word before. We've got access list 104, TCP, any source towards this destination established. So you notice it's a different number, so this is a different access list. So this is actually in the other direction, checking traffic from the other way. Does anyone know what established means?
It's TCP traffic that is established.
Basically, any packet after the SYN. It won't allow a SYN, but it will allow a SYN-ACK ACLs, and of course normal traffic. Yeah, they were trying to sort of make it stateful. It's a bit of a blunt tool, stateful, but it's stateful. The problem is, if you Cisco added this extra functionality in the ACLs, and within 2 weeks, people had already found a way around it. Because most hosts, if you send them a SYN-ACK instead of a SYN, at least at the time, they would respond with another SYN-ACK.
Yeah, right.
So
Pretty simple.
So as soon as that was found, Cisco went back to the drawing board and made a more advanced features. But anyway. Okay. So as I said, applying these ACLs to an interface, again, is much the same. IP access group 103 inbound, access group 104 outbound. So of course it's on this gigabit interface. And so of course the outbound of course is the traffic, because it's for the gigabit interface, it's leaving and going towards the hosts. And so that's that one with that established. The other one is the outbound, and though it's inbound for the router, it's going towards the internet. And so of course that's the that's what kind of traffic's allowed out. Now, do we remember from CCNA 2 what is implied at the end of every ACL? What's that? Deny any, basically. Or in this case, because we're talking about extended, deny any. So it's a deny IP any. And so basically, if you remember, you have to have at least one permit statement on your ACL. Otherwise, you may as well just unplug it. It's a lot easier than writing an ACL. So you've got to think about, you've got to really, as I said, you've got to really plan it. And so, of course, I think if you guys have done some programming, I assume, it's sort of a bit the same kind of, you've got to have these logical order that you do these things. Of course, there's not a lot of iteration, but there is a lot of sequence. Okay, so some more examples. So now FTP has always been a bit of a bugbear on firewalls, because FTP uses the 2 ports on the server, and so you establish your connection with port 21, but when you do a data transfer, it comes from port 20. So with stateful firewalls, that can be a problem. So often you need to actually add special modules to your firewalls to sort of support that. I suppose FTP does seem to be getting less and less relevant. Hardly anyone's using it anymore, but it's certainly something you should consider. So when it comes to named extended access lists, basically it's pretty consistent with a named standard. You just do the extended name in there. We're calling this surfing, and so then it's the same lines as what we had before. Of course, again, because we're within this different config mode, it actually you don't need to specify which list it belongs to because you're in that mode. So we've got surfing and browsing. So surfing is the outbound, the browsing is the inbound, apparently, from the internet anyway. And so applying them to that interface, and so that's basically the same example as what we looked at before, but in a named version. Again, how do we check that it's working or where it is? So show access lists again. And you can also do show IP interface. And so you can actually see that you've got outbound list for browsing and inbound for surfing. Now, one thing this isn't showing, if you do show IP access lists, On an active router, it will actually have a number beside it saying how many matches it's had for that every individual line. Now remember, there is that implied deny any or deny any depending on standard or extended. If you actually specify that line, you'll actually get a count for that as well. But the implied lines aren't shown, and so many people actually do that implied line themselves just so that they know sort of the statistics for which line is going, which line is active most often. It's a good way of testing that your access list works. Now, editing access control lists. Now, give us a sec, another drink. Now, if you've got numbered access control lists, at least up until recently, you couldn't really edit them. And so what most people did was that you would actually, what I did at least, I'd do a show run, and of course the access lists are in the running config. Then I'd copy them out of that, paste them into a text editor, and then you can edit it. And then all you need to do is, let's just say we're talking about access list 10. In the editor, you just put a line at the very top, no access list 10. And then all your lines, which you've then edited. So if you do no access list 10, it will wipe out the entire access list. And then you can have your new ones go in. So that's the way most people did it. And so you'd have your access lists in a text document, you'd edit it, and then if you want to change it, you just change that document, and you just have that no access list 10 line on the very top, paste it into the router, instantly it blows away the old version, puts a new version in, and away you're off, as long as you haven't made any mistakes. Now, there is another method now in more modern iOSs where you actually go in and pretend it's a named access list. And so you do IP access list standard and you just type in 10. It will actually then allow you to edit it. Now you'd need to do show access lists first so that you know what the numbers are. So what I would normally do is probably copy and paste that into a text document. And then from there, you can actually delete a line number that you want to get rid of. And so as you can see here, where is it? No 10. So you're actually blowing away the original line 10. And then you do 10 permit TCP. And so basically what that's done is it's taken away the old line 10. We've added a new line 10, the one we want to edit. And so that's basically the way you do it. And of course, if you wish to edit named access lists, that's actually one of the advantages. That was at least one of the advantages of having named access lists, is you could edit them fairly easily. Now, IPv6 does not have standard ACLs. There are just IPv6 ACLs, and that's it. There is nothing else. Now, IPv6 actually has 3 implied statements in it, because we have neighbor solicitation and router solicitation. And so you actually have to let that traffic in. The hosts need to be able to find the router. And so we've got these 2 permit lines there. And so those solicitation messages are through ICMP. And so permit, ICMP, any, neighbor solicitation and neighbor acknowledgements, or advertisements, sorry. Of course, there is still the deny IPv6 any statement. So how do we configure IPv6 ACLs? And so we have, of course, a set up IPv6 network. And so there are no numbered IPv6 ACLs either. They are all named. And so the command is just IPv6 access list, give it a name. So you don't need to specify standard and extended because they're all extended, so why bother? And then, of course, so you just need to give it a name. And then from there, you put your lines in, like any other access control list. Now, there are no wildcard masks with IPv6. Basically, you can define your mask and that's it. And so, deny IPv6, this source subnet to go to any other address, permit the rest. So that's what this one does. And so apart from that, the syntax is the same as extended IPv4 ACLs. You've got source ports, destination ports, specify protocol again. You've got IP, ICMP, TCP, UDP, etc., etc., etc. You can use any host, of course, and away you're off. Now they've changed it, applying it to an interface. It's not access group anymore. It's traffic filter. Suppose it is a little sort of more logical if you're reading that it's sort of more explanatory than access group. But yeah, they've changed things. Anyway, apart from that, so it's IPv6, traffic filter, and then you just give the name and the direction. So it's roughly the same, but they've changed the name of the command. And so here's an example. And so IPv6 access list restricted access. Again, you change config modes, and then you do, in this case, they've done a remark, and so then they can just put a comment in, and then we put in a statement. Permit TCP any, so any source to this destination with this port number. So this destination here must be a web server, because it's 80 and 443. Okay, and so deny all other traffic to the network. So we wish to block any other traffic to that destination. Permit PC3 telnet access to PC2. And so permit TCP this source host to this destination host using port 23. Deny all other telnet. Deny TCP. Yeah, sorry. And then the last line there is permit IPv6 any. And so how do we check it? Again, there's show IPv6 interface. And of course there's show access lists as well. So how do we troubleshoot? So basically, first part of troubleshooting is understanding how they operate. And so of course, inbound ACLs behave as follows. The information in the packet header and the ACL statement match. The rest of the statements in the list are skipped. The packet is permitted or denied as per the statement. If a packet header does not match the ACL statement, it's then tested against the next statement. And it keeps doing that until it finds either a matching statement or it finds the end of the list. If it hits the end of the list, it will be denied. And so outbound, basically it's the same. But of course, if it's an outbound one, it actually gets routed first. So it knows what outbound interface it's got, and then is there an outbound ACL that applies. And so from there, it then tests it much the same as it did before. When a packet arrives at a router interface, the router checks to see whether the destination layer 2 address matches the layer 2 address of that router. If the frame is accepted, the router checks for an ACL on the inbound interface. If that exists, the packet is tested against the access control entries, and of course whether it's permitted or denied. If the packet is permitted, it is then checked against the routing table, of course. It's been permitted, it then needs to be routed towards its destination. If the routing table entry exists for the destination, the packet will then be switched. And then, of course, it goes to the outbound interface. And again, is there an ACL? It will be checked against the access control entries. If one matches, it will be permitted or denied. If it doesn't match, it will be denied. Of course, then it's re-encapsulated in the new layer 2. So again, standard ACLs only can be matched with source IPv6 addresses. The Cisco iOS software tests addresses against the ACL access control entries. The first match determines whether it gets accepted or rejected. Because the software stops testing conditions after the first match, the order of conditions is critical. Of course, if there are no matches, goodbye packet. The extended ACL, of course, can be on protocol, source address, source port number, destination address, destination port number. The ACL first filters on the source address, then on the port, then on the protocol of the source. If it then filters on the destination address and the port protocol, and then if it all matches, then it will actually do the permit or deny. So the most common ACL errors are entering ACEs in the wrong order or not applying adequate criteria to the rules. So basically, test changing ACLs on a live system with lots of clients, not a great idea unless you prototype it first. And so you really do need to have some kind of test environment. And so from there, test it, make sure it works as per expected, and then make those changes on your live network, basically. Now we're showing here that we've got denied TCP from that source to any destination. And of course, basically, you look at them, they're identical, apart from this one is more specific because it specifies a protocol. But anyone that would match this will match that. And so this line will never be run. And so basically we're denying all TCP traffic. And so this TCP telnet traffic won't get through. And so only traffic will get through is traffic that's not TCP. So UDP, ICMP, that will all get through because we've denied all TCP traffic. And so, as it says, we need to swap lines 10 and 20. Now the example here, line 10, permits telnet, denies SMTP, which of course is email, permit TCP any. Now, the problem with that is TCP traffic, that's all sorted. But that's only one facet of traffic. We haven't permitted IP, and so any UDP traffic will be blocked. And apparently they want to get TFTP through. That deny IP any on the end, that's implied, will block all UDP traffic. It will block all ICMP traffic. So if that was your intention, great. If you want to get UDP traffic through, most people do want to get some through, because DNS also uses UDP. So yeah, you've got to think about that. So what's going on here? We've got deny TCP any destination equal telnet. So that's actually the source address. Any source host with telnet. So I'm assuming return traffic from a telnet server to any destination, that's going to be blocked. Now, from their solution, I think they're actually talking about going towards a telnet server. So basically, this is blocking traffic in the wrong direction, basically. And so basically, they want the destination to be a telnet server, not the source. So basically, that's what they've gotten it wrong. Another example, we're looking at show access lists. Host is able to connect to telnet and connect to, but the company policy states that this connection should not be allowed. So here, I think it was meant to have been 12 instead, sorry. I think it was supposed to be host 12 and not host 1. Again, human error. Lots of examples. So, in this example, the 11 network can use telnet to connect to the 30, but according to company policy, that shouldn't happen. Again, we're trying to connect to a telnet server, should be on the destination side, not the source side. So again, we can telnet so this one isn't matching. Where's it applied? Inbound. Again, host number. How boring. Oh, more telnet. Too much telnet. IPv6. There you go. That's something different. In this example, R1 is configured with an IPv6 ACL to deny FTP access from the 10 network to the 11 network. However, after configuring the ACL, it was still able to work. And so we've got this show IP access list. Deny TCP. It's applied outbound. So instead of going into the router, it's applying it outbound. And so it's just applied in the wrong direction. So permit IPv6 any source to that network. So we did 10 instead of 11, I think. Too many. Okay, good. Too many examples. So chapter summary is that we've looked at, by default, routers will forward traffic. When you apply an ACL, basically it will try its darndest not to route traffic with those implied deny IP any-anys. So of course an ACL is a sequential list of permit or deny statements which are defined in the access control entries. When a network traffic passes through an interface configured with an ACL, the router compares the information within the packet against each entry in sequence until there's a match. If there's no matches found, the packet is dropped. You can apply ACL access lists either inbound or outbound on an interface. Got to take it from the perspective of the router. Standard ACLs can be used to permit or deny based on source IPv4 address only. Extended ones, source and destination, addresses and port numbers. The access list command, of course, is how we define the access list. Of course, numbered ones, you need to specify the number of the list. With named ones, of course, you specify the name and then you go into a sub-config mode. You apply IPv4 access list with IP access group. Now, one thing we did do in CCNA 2 was you can apply access lists to the VTY interfaces, which is a very, very handy thing. And because we already know the destination, all you need to do is specify, because, hey, it's being applied to the VTY interface. It only means it is either Telnet or SSH. And so you only need to specify what sources you'll permit and deny. So it is a great system. So you can restrict Telnet to that router, but it'll actually let all other Telnet traffic through. It'll route that. So it's a great system. And so, of course, with IPv6, we define it with a named ACLs only. And from there, of course, you do the access control entries in that sub-config mode. You apply it using the IPv6 traffic filter command instead of access group. And of course, again, inbound or outbound. There are no standard or extended access lists in IPv6. They're all extended, basically. So you don't need to specify. There's the logo.